welcome back to Cambridge Guru once again. I hope all of you are doing good. We have already started the AP Calculus, and in that we have done Unit 1. Not we are doing actually Unit 1, in which we have covered the first topic, in which I introduced you in the last video about the different types of number systems, and we also did the modulus function, and we also talked something about the inequalities, and there we also did different types of inequalities, some questions which involves linear inequalities, how to solve modulus inequalities, quadratic inequalities, and a modulus inequality which involves quadratic functions. Okay, this is all we did in the last video. Now this video is about next topic, which we say is the starting point of your calculus, which is functions. So without any further delay, let us start. So we have a topic which is functions. So in simple words, we say that function is a type of machine in which we give some input and we get some output. Okay, although there are certain restrictions that not each and every relation between any kind of variables is not called as a function. There are certain restrictions, right? So let us say before that we will first write that how we denote the function. So function are basically denoted by the letter F, and since in this calculus course we are only dealing with single variable, right? So we write that variable in which the function is defined inside the bracket like this. So we say that there is a function fx, right? This x denotes the variable in which, or the input variable which is going to the machine. Okay, and correspondingly you are finding an output based on this input x. So we write this as output as y. So we say that there is a function y is equal to fx. Okay, in the functions also we define two types of variables. See, basically the calculus deals with the phenomena which are happening in nature, right? Although the phenomena which are changing in nature. So we introduce certain kind of variables inside that picture, inside that phenomena, and try to find out what are the dependent variables and what are independent variables, right? Dependent variables meaning is the values or the variables whose value depends on certain kind of variables. Those variables on which the value of other variables depend are called independent variables. Meaning is you keep on changing the values of these variables, right? Depending upon these values, you will get the value of different kind of variables, right? So in a situation, we define the variables into two categories. One is independent variables and other is dependent variables. Independent variables in two variable system or two variable function, the independent variables are denoted by letter x, right? And the dependent variable are denoted by y. So as I told you earlier, that the function is a kind of a machine in which the value of y variable depends on value of x variable, right? So we say that x is the input variable, and this is called the independent variable. This is the independent variable, that independently you can change the value of this x. Depending upon this x, you will get certain kind of value y, depending upon the definition of the function. Okay, so if I write the function as x plus 2, this is the definition of the function. This is the definition of the machine. What this machine does is that it increases the input by 2. So if the input is 4, you are getting value of y as 6. If the input is -1, you get value of y as +1. If the value is 0, you get value of y as 2. So as you can see here, that for each and every value of x, you are getting different values of y. So y is the dependent variable. Dependent variable. Okay. Also, we can think of the function as a mapping. Mapping in the sense that if I consider the input set denoted by x, meaning of input set is all the values of the input which are going into the machine, I collect those values and put it inside a set, form a set that is called the input set. So we have all the values here, x, x1, x2, x3 and so on. Depending upon these values, you have an output set denoted by y, right? And it consists of variables, let us say y1, y2, y3 and so on. Okay, so for each input we have a corresponding output in the y set. Okay, so we say that this if input goes x1, right? So according to the definition of x and of the function, what this does is that fx will gives you x plus 2 in this particular case, right? So if variable input is x1, then y1 value you will get as x1 plus 2. We say in this case is that x1 is mapped to y1 like this. We say that x1 is mapped to y1, right? And if x2, if input goes x2 and let us say you are getting the value as y3, okay, and x3 is mapped to y2, right? So the way the input and output variables of two sets are related, are connected to each other, right? This scenario is called mapping. How the input and output variables are related to each other, are connected to each other. How they are connected? According to the definition of the function x plus 2. Okay, so this is called mapping. This is one kind of mapping. Now, how the input and output variables are related? There can be number of ways in which x1 can be mapped to y1. It is not necessary that x1 should be mapped to y1 also. There is another kind of mapping in which we can map x1 to y2 also. Okay, so next topic is at how we can define different types of mapping. Okay, so basically this is the not the formal definition of function. We will do different types of topic and then arrive at a formal definition of the function. Okay, so because there are two words in the formal definition of function which are required to be understood in detail. Okay, so next we are doing is mapping. Okay, so one type of mapping is that suppose we have input variables as a, b, c, d and so on, and output is denoted by let us say p, q, r, s and so on, right? And so we have, if we have this type of mapping that a is related to p, b is related to q, let us say c is related to s, it is not necessary that it goes straightways. Okay, so and d is related to r. So this type of mapping is called one-to-one. One-to-one meaning is that single element of the input variable is mapped to or related to only single element of y set, right? So input variable are mapped to only a single output variable. So we say this is kind of a one-to-one or just one-one mapping. Okay, this is type 1. Second type of mapping is that we have input set, output set, variables are let us say a, b, c, d, and here we have let us say this time x, y and z. And one mapping is let us say a is related to y, b is related to x, c is related to z, and also d is related to z, right? So if you notice here that a is related to y, only single element, b is mapped to x, another single element, but in this case both c and d are related to a single element d. Okay, so multiple inputs are mapped to a single output in the output set. So this kind of mapping is called many to one. whatever word is coming before or at the first, that means we are talking about the input set. So we have many, that means many inputs are mapped to a single output. This is called many to one mapping. Okay, second type. Now you must have realized that what other kind of mapping could be possible. If there is one and many one, then there are certain type of mapping which are just opposite of this. So we have the third type of mapping. We have the elements as A, B, C, D, and then X, Y, and Z. This time A is related to X and also A is related to Y, right? And C is related to Z. And let us say D is not related to any variable in the output set. Okay, it is also possible as far as definition of relation is concerned. Mind it, I'm not saying this is possible for function. Okay, why I have deliberately used this is because this will be again used in the formal definition of the function. So for now, let us concentrate on only mapping. So we have here that there is a single element which is mapped to more than one variable in the output. So this type of mapping is one to many, which is just the opposite of second type. One to many mapping, and fourth one is just the combination of all these mappings, which is called the many to many mapping, meaning multiple values of the input are related to multiple output values. Okay, so let us say we have A, B, C, D, X, Y, Z. Okay, and mapping is, let us say A is related to X, A is related to Z, B is also related to X, C is also related to Z, and also D is related to Z. Okay, without leaving any input variable. Okay, so this type of mapping is many to many, that there are multiple inputs for a single output or vice versa. Okay, multiple outputs for a single input. Okay, so many. Okay, so this is the types of mapping. Now out of these four mappings, only two mappings are allowed as far as function of definition of function is concerned. Okay, only two mappings are allowed. You may note down. Only two out of above four mappings are allowed as far as definition of function is concerned. Why we are saying this? Let us take an example. Is concerned. Let us take an example. Okay. I hope all of you have heard about the law of gravitation. Okay, this definition of function within this example I always give when I whenever I teach functions. So we have law of gravitation given by Newton. It consists of the formula G, which is the gravitational constant, m1 m2, which are the masses of two, let us say, heavenly bodies, two planets or moon and earth, any heavenly body you can consider. So m1 m2 are the masses of two heavenly bodies, and r is the distance between their center, so it is given by r square. So f is g m1 m2 by r square, and let us say these are two heavenly bodies. Okay, this is the center, this is the center of, this is m1, this is m2. Joining these, this will be your distance r. Okay, so law of gravitation is given by gm1 m2 by r square. Now in this formula we say that g is the gravitational constant, meaning this is a constant, and considering the masses of planets also constant, because we are not going deep into the physics that masses also changes, masses also change, but considering these as a constant, so G, M1, M2, which is the product of these three numbers, I can consider this as a constant K. So I can rewrite this function, this F force of gravitation, as K by R square. K is a constant, multiplication of G, M1 and M2. Meaning is that the value of gravitation force between two heavenly bodies, it only depends upon the radius or the distance between the center of the heavenly bodies, considering masses of two heavenly bodies constant. Okay, so it only depends upon the distance between these two bodies. So I can call this F, I can call this gravitation force of attraction as a function of the distance between the bodies, or as a function of R. So I can rewrite this as F is just a function of the variable R, whose definition is K by R square. Okay, so this gravitation force of attraction is a kind of a function. Why I am saying this as a function, and how the mappings, only 2 out of 4 mappings we can see in this definition. Let us extend this concept. If I am saying that only 2 mappings, what are those mappings? Is I'll say that which are not allowed. Okay, I will say that a mapping which is of the type one to many. One to many is not allowed. Okay, one to many is that for a single input there are multiple outputs. Okay, meaning is that for a single, in this context, if R, for a single value of R, let us say you are finding out the gravitational force between moon and earth, right? You have fixed a position of R, let us say R is how much? Let us say 1 lakh kilometers. Okay, so for this single 1 lakh kilometers, you cannot find different values of force of attraction. Okay, it makes sense that gravitation force between moon and earth for a single value of R will remain constant no matter they revolve. Okay, at another position, if this moon or this moon comes here, okay, but R is constant, so we say gravitation force is constant, and that's why we can say that moon is a satellite which keeps on revolving around the earth, because the gravitation force between earth and moon is constant, means moon is revolving or rotating around an orbit. Okay, so that's how we, we give the satellites in the space, we send the satellites in the space which keeps on revolving around the earth, artificial satellites in their respective orbits. Okay, and there is physics involved in calculating the distance above the earth at which it will never fall down. Okay, it keeps on revolving and revolving because the gravitation force will remain constant. Okay, so not going deep into the physics, again coming back to the definition of the function, meaning is for a single value of R, for a single value of input, multiple forces are not allowed. That's why one to many cannot be called as a function or cannot be included in the definition of function. Okay, and second is why many not many. So if many not many includes one to many, that's why it is just an extension of one to many. Okay, hence only 2 types of mappings are allowed, which is one to one and many to one, right? Second case is, let us consider this third type of mapping again. In this type of mapping, this element D was left out. This element D was left out. Left out means you do not find any value of Y corresponding to this input D. Meaning this D is not allowed in the input, though it is in our bag, but we cannot give into the machine because there is no output for this corresponding input. It is not mapped. So this is also not allowed in the definition of function. Now, understanding this in the context of the gravitation force, we will say that you cannot find any position, you are not finding any value of r where you cannot find any force of gravitation. Can you tell me a distance where you cannot find out force of gravitation? Either this distance can be infinite, which is very large, or it can be very small. But you cannot find that at this place you are not finding the value of gravity. Either it will be infinite if r is 0, and considering r is 0, it is also not possible. It might be in the nanometer. Okay, now you are going into the quantum mechanics. Though at the quantum level, Newtonian theory, it fails, but nevertheless, meaning is that you keep on reducing this distance between two bodies, you cannot make it to be 0. First thing is this. Okay, and if it is 0 somehow, then also we say that it is not defined, or it is very big value. Okay, but you cannot say that at this value you are not finding any value of force. Okay, it doesn't make any sense. So as far as definition of function is concerned, for each and every value, for each and not for each and every value of the input must be occupied by its output value, right? Each and every value should be mapped to some output value, right? There should not be any element left inside the input set. So as far as function is concerned, this is not allowed, though mapping is allowed as far as mapping is concerned. Okay, but when we deal with functions, this d element should also be occupied. Okay, now having understood all these concepts, let us arrive at the definition of the function. It says that a function f from a set d, I will call this as d, or this is calling as d, I have called this as input set x, because normally input variables are called as x. So function f from set x to set y is a rule which assigns to each element. Okay, this each element is very important. The talk which I have, or the concept which I have just told you, that each and every element must be occupied in the input. So to each and every input, it assigns. What assigns? The rule. Okay, the rule that assigns to each element x in D a unique element in Y. Unique element in the sense that one to many is not unique. In this mapping, when I was saying that one to many is not allowed, we say that for a single input, you are getting multiple outputs. Meaning is for r equal to 1 lakh kilometers, you are getting force of gravitation as F1 also and F2 also. So these values are not unique to certain kind of input. So this is not unique. So this word unique is very important. Okay, so there must be one input. Okay, there cannot be multiple. Again I'm saying there must be single output for each and every value of the input. Okay, there cannot be multiple outputs for a single input, meaning one to many is not allowed. Okay, let us reread the definition that a function f from set d to set y is a rule that assigns to each element, meaning there should not be any element left in the input set, a unique element y in the output variable. Unique element, right? So it is written like this type of mapping, that function f is defined from input x to y, that output elements of y are related from input elements of x. This is the input set, this is the output set. Okay, next topic is domain and range, right? Before that, let us learn one more concept, which is the vertical line test. What this vertical line test is, it is to test that not each and every curve can be called as a function. Okay, so for the mapping which is one to many, meaning is before that, just a second. If I consider a graph, let us say y is equal to x square. This is a quadratic function. I will call this now as a function, right? This is a quadratic polynomial y equal to x square whose graph is like this. Okay. Now, if I put x is equal to -2, y is 4. And if I put x equal to +2 also, y is 4. That means this is -2, this is +2, and you are getting value of y as 4. So we have multiple inputs and a single output. This type of mapping is many to one. So is this allowed in the function of in the definition of the function? Yes. For multiple values of r, force can be single. You can have value of different values of r to get a single value of f, but you cannot have single value of r and multiple values of force. So one to many is not allowed, but many to one is allowed. Okay, in this whole universe you can find a point or more than one point where force of gravitation is same. Okay, so many to one is allowed. So this y equal to x square is indeed a function. Okay, but if I reverse this, let us say x square equal to y. In this case, for y is equal to 1 and for y is equal to x equal to x square equal to y, let us say y is 4. Okay, y is 4 and y is -4. So in this case you will say that for a single value of x you can have y as +4 and -4. Okay, its graph will be like this. Its graph will be like this. Okay, so this is not allowed because for a single value of x you are getting multiple values of y. For single value of x we are getting multiple values of y. Okay, so this is +4 and this is -4, right? So this is not allowed because this is a kind of one to many mapping. Single input, multiple outputs, one to many mappings. Okay, so how we will test whether the given graph is a function or not? In order to identify this, we have a vertical line test. So any graph is given to you, what you do is you sketch a vertical line. If that line is intersecting at more than one point, if any vertical line, vertical meaning is it must be perpendicular to the x-axis. If it is intersecting the curve at more than one point, like in this case, then the graph will be one to many and it will not be a function. So this is not a function. So this is a test to identify whether the graph is a function or not. Okay, and if you draw a horizontal line and if it is intersecting at more than one point, that will be a many to one function. Okay, there are certain kind of functions which are one to one, but those functions we will do when we will do inverse function. Okay, so this is about vertical line test. The next topic is domain and range. So as I told you, domain are the allowed values of x. In simple words, domain are the allowed values of x, or we can say the values of x meaning the input which is going to the machine, the values of x at which function fx is defined. Function fx is defined. Okay, for example, if I say we have the function given as x minus 2. Okay, so x minus 2 meaning is, can you find out any value of x from minus infinity till plus infinity, means in all the domain of the real numbers. Okay, can you find any number of x, any value of x at which you don't have any value of x minus 2? Okay, are you thinking? Yes. I mean, the answer is no. There is no such value of x at which you cannot have a value of fx. Though this x can be infinite, so value of y will be infinite. So that infinite we will consider. Infinite is a very big number. It is not something which is not defined. Okay, it is defined in the sense that it is very big. It is just a symbol to represent something which is big, which has not been found out yet, but definitely we know it is very big. Okay, so for all the values of x, this function will give you some value of y. So we say that domain, I mean the values of x. Okay, so domain in this case is, we always write domain in terms of x. Okay, what are the values of x? What are the values of input? So we say that x belongs to, this symbol is standing for belongs to a set all real numbers denoted by r, which we have learned in the previous lesson. So x belongs to R is the domain for this function. What about fx equal to x square plus 2x plus 1? This time this is a quadratic function. Quadratic in the sense whose degree is 2. Okay, I'm not going into the types of functions. Okay, if need arises, I will do this, but I hope you know the types of function that we start with the constant function. And depending upon the degree, we have the functions. Okay, if degree is 0, we have a constant function. If degree of the variable, highest degree of the variable is 1, we say this is linear. Okay, this one, if degree is 2, this is your quadratic. If it is 3, we have cubic, and so on. Okay, so this is quadratic function, and again in this case you will find out for each and every value of x, you will find out a unique value of y. You cannot find out from minus infinity till plus infinity any value of x at which function is not defined. Why I can say this? Because I know that this is a quadratic graph, quadratic function, and its graph will be like this. Okay, this will be minus 1 to be more precise. X is minus 1. Okay, so from this minus infinity till plus infinity, the function is defined, right? So again in this case, domain is given by R. Now let us consider another function, which is fx is equal to, this time cubic, 3x square plus 2x plus 1. Okay, and its graph will be something like this. Okay, it may intersect the x-axis, which will give you a single root. It may not intersect the x-axis at more than 1, which will give you only a single root. It may have 3 roots if it is intersecting at 3 points. It may not have 3 real roots. Okay, so we are not going into this, how many roots this cubic equation will have, but we are considering basically the polynomial functions. Okay, and I hope you know what are polynomials. Okay, the algebraic expressions in which the degree of each variable is a whole number. Okay, negative powers are not allowed. Any expression which is having a negative power, for example, the expression of the type px equal to x plus x raised to power minus 1, written as x plus 1 upon x. So this is not a polynomial. Okay, pardon me if I am digressing from the concept, because we were actually doing the domain, functions domain, and now I am defining polynomials, but I don't know if your basics are clear or not. So we are dealing with the polynomial functions whose degree is always a whole number. So this is a cubic polynomial. So we have a statement here that every polynomial function domain will be real numbers. So each polynomial function is defined from minus infinity till plus infinity. Okay. So domain for all the polynomial function, we write this as x belongs to R. Okay. Now what about, consider a function fx equal to 1 over x minus 1. Now this time, as you can see, that for any rational number to be defined, remember the definition of a rational number, that any number which can be represented in the form of p by q, where this q should not be equal to 0. Okay, means denominator 0 is not allowed. Now here in this case, if I put x equal to 1, if x is equal to 1, then we say that fx will become of the type 1 by 0, which is not allowed. Not allowed in the sense that we cannot find its value exactly. Okay, so this is not allowed. So what values of x are not allowed in this machine? If the machine is defined as 1 upon x minus 1, so x equal to 1 should be kept out of the domain, right? So we define the domain of this function like this, that x belongs to all real numbers except one particular value 1, and those particular values, those values which are defined to be particular in the sense that for only this single value, discrete value, always are written in curly brackets. Okay, square, I think I have told you in the last class, in the previous video, the types of brackets, right? Parentheses in which end values are not included, square brackets in which end values are included, and curly brackets are those which are for only discrete values, some particular values. Okay, so this is the domain for this particular function. So domain basically meaning is allowed values of x. And what is range? Okay, another concept is range. Range is the values of y for a corresponding value of input. Okay, and it is a set. So just like domain is a set of all the input values, we have range as a set of the output values. Okay, and there is a concept of codomain also, but we are not going deep into codomain and range. So we just consider the output set as a range. Okay, all right. Now let us understand the method of finding out the domain of functions for any type of functions, right? So method 1 is that any function which is of the type 1 over a. Method 1 is type 1, not method 1. I should use the word as type 1. There are only two types of function in which you need to find out the domain. First type is 1 by a type. A means any kind of algebraic expression. If it is written in the denominator, so we say that this denominator should not be equal to 0. It may be positive, it may be negative. So just like in the previous case, I took the example of x minus 1. So x equal to 1 is not allowed in this case. How we arrive at this x equal to 1? That we put the denominator, in this case a is x minus 1. So we put this denominator x minus 1 should not be equal to 0. And just like you solve the equation, you solve this, whatever you call this as, I even cannot call this as inequality. Okay, so this is not equal to 1, that x should not be equal to 1. Otherwise, all the values are allowed. Okay, example number A, example number 2, for example 1 upon x square minus 2x plus 1. Okay, this is again a quadratic function. That means domain for this is given by that this x square minus 2x plus 1 should not be equal to 0, right? And this is a quadratic function, meaning x minus 1 whole square should not be equal to 0. So again, x equal to 1 is not allowed. So domain is given by x belongs to all real number except 1. Okay, you may consider another quadratic function also. Let us say 2 by x square plus 5x plus 4. Okay, so writing this as 2 by x plus 4 into x plus 1, meaning is that x plus 4 and x plus 1 should not be equal to 0 for defining the domain. Okay, that means x should not be equal to minus 1 and x should not be equal to minus 4. Rest all the values are allowed. So we say that domain is x belongs to all real numbers except minus 1 and minus 4. Okay, remember I told you that particular values should be written in curly brackets. Okay, if I write this minus 1 and minus 4 in parentheses or square brackets, it indicates all the values which are lying between minus 1 and minus 4. So minus 2, minus 3, minus 2.1. So all these infinite numbers will be included in this parenthesis. Okay, so this is not equal to this. Okay, only minus 1 and minus 4 are not allowed. So curly brackets you need to use. So this is type 1. And type 2 is of the type, any function of the type which is inside the square root. Okay, because this is again, similarly you can define for cube root also, right? But cube root for negative numbers is allowed. Fourth root also you can define. So I'm just taking the square root of a, right? Why I'm saying this? Let us consider an example that square root of, you need to find out the domain of this function, x plus 2. Right, now you very well know that square root is only possible for the positive numbers. That means this x plus 2 must be greater than or equal to 0. For 0 also you can find out the square root, which is 0, but this should not be negative. Okay, so in order for this function, which is a square root function, to be defined, this x plus 2 must be greater than or equal to 0. Right, that means x should be greater than or equal to minus 2, and this is the domain for this. It's what it says. It simply says that x should be greater than or equal to minus 2. Right? Oh really? What about if I put x equal to minus 3, which is less than minus 2? If you put x equal to minus 3 here, it will become minus 1, which is not allowed. If you put, let us say, minus 100, so it will be minus 100 plus 2 minus 98. Again, negative inside the square root. Not allowed. Alright. And what if I put x equal to 0? Yes, because 0 is greater than minus 2. So under root of 0 plus 2 is root 2, which is allowed. Okay, so for this particular function, we say that domain is x greater than or equal to minus 2. Okay, and in terms of real numbers, if you have to find out the domain, you can also write that all real numbers except what, that x should be less than or equal to 2. Okay, and it makes no sense. Okay, except again you are using the variable inside the variable, so this is not the way to write. Simply write domain is all the values of x which are greater than or equal to minus 2. Right, let us take another example. Inside the square root, this time you have x square minus 3x plus 2. Right, again this is quadratic, so please do not forget the concept. There are only two types of concept, that inside the function, inside the square root must be greater than or equal to 0, and below the denominator, right below the numerator, the denominator should not be equal to 0. So we have a square root, that means x square minus 3x plus 2 must be greater than or equal to 0. Simple. For this square root to have some value, so we can factorize this. This is now a case of a quadratic inequality, which we have learned in the previous video. This is x minus 2 and x minus 1 greater than or equal to 0. Right? So leading coefficient is positive. Roots are 1 and 2. So solution, this is 1, this is 2, plus minus plus. So outside the root is a solution. That means is x is greater than or equal to 1, or x is less than, greater than or equal to 2, or x is less than or equal to 1. Only these values are allowed. The values between 1 and 2 are not allowed. Okay, less than 1 or greater than 2. So if you put x equal to 1.5, let us check this, whether you are able to find out the square root of a number x, which is, lying between 1 and 2 in this case. So for 1.5, we put x as, so here we have 1.5 minus 2. Let me write this, 1.5 minus 2, 1.5 minus 1. So 1.5 minus 2 is minus 0.5, this is 0.5. So minus, this is plus, minus into plus is negative. So under root is coming out to be negative. So not allowed. Okay, so domain is x less than equal to 1 or x greater than equal to 2. So we can write this in terms of parenthesis this time, that x belongs to minus infinity till 1. 1 is included. You can write this with a square bracket, union, because or indicates union, x should be greater than equal to 2. Okay, so 2 is included, and infinite are always written with parentheses. You cannot write square bracket whenever there are infinites in the set. Okay, because this is not an exact value of certain number. Okay, so infinite plus 1 is again infinite. Okay, so that's why always put parentheses that this is not included. Okay, so this is the domain. Fine. So yes, next concept is zero or root of a function. Zero of a function, as the name suggests, that the values of x at which the function is getting the value 0. Okay, all the values of x where the function is becoming 0. Graphically is that function becomes 0 whenever it crosses the x-axis. Right? If I write y is equal to x minus 1, so it simply indicates graph is like this. This value is minus 1, this value is plus 1. So graph is becoming 0, meaning the value of this straight line is 0, meaning it is intersecting at the x-axis. At which point? At x equal to 1 point. So where y is becoming 0, meaning is find the value of x where it becomes 0, so x equal to 1. So we say x equal to 1 is 1, 0 of this function. Okay. Now you may note down value of, not the value of, you can write the degree of a polynomial function, degree of a polynomial function determines the possible or maximum number of zeros. Number of zeros of a function. Degree of a polynomial function determines the possible number of or the maximum number of zeros that function can have. Okay, so if we have a linear function of this type, this is a linear function having the degree of variable as 1, so it will have only 1 0, which is x equal to 1. Okay, if you have a quadratic function of the type y is equal to x square minus 2x plus 1, not minus 2x, let us put minus 3x plus 2. Okay, so it will have two zeros, one is minus 2 and one will be 2 and one will be minus, one will be plus 2 and one will be plus 1. Okay, earlier what we did, and graph of this will be 1 and 2 like this. Okay, so as you can see that this function is intersecting the x-axis at 2 points. 1 is plus 1, 1 is plus 2. So this quadratic function, which was having a degree of 2, that's why maximum number of zeros can be 2. And why I said possible or maximum number, because there are certain kind of quadratic function which will not give you any roots. For example, y is equal to x square plus 1. You can put any value of x from minus infinity till plus infinity. You cannot make this as 0. Meaning is that this graph of fx will always lie above the x-axis in the air like this. This intercept is plus 1. It will never intersect the x-axis. And if it never intersect the x-axis, meaning it will not have any roots, though the degree is 2. That's why it is not always necessary that for a quadratic equation, for a quadratic function, you always get 2 zeros. No. Okay. These are possible. These are the maximum number of zeros. Okay. We will talk later on sometimes. Similarly, for a cubic, it will maximum can have 3 roots. It is not necessary that always the cubic function will intersect the x-axis. Okay, I'll give you one example for this graphically, that there are certain cubic function which are intersecting the x-axis only at one point and they keep on increasing. Okay, and there are cubic function which are intersecting at 3 points, which may intersect the x-axis at 3 points, 1, 2 and 3. In this case, it will have 3 zeros, and in this case, it will have only 1 zero, though polynomial is cubic. Okay, so this is about the zeros wherever the function is intersecting the x-axis. So as the slide was saying, at this point, C, it is intersecting, so we say this is the 0 of fx. Okay. Let us do one question, couple of questions. The graph of the function f is shown like this. Find the values of f1. So f1 meaning is value of function at x equal to 1. Okay. So x is 1 here. This is x equal to 1, this point. And the value of function is this, which is 2. Okay. So I will say f1 is 2. And at 5, 1, 2, 3, 4, 5, this is 5. And value of the function is slightly. This is 0, 1, 2. Okay, this is 5, so I will say it is slightly above the 1 point, and if I consider it as though intersecting, if it is actually intersecting at this point, so we say this is 5, value of function f5 is just 1. Okay, what are the domain and range of f? Domain means all the allowed values of x. So as you can see, the graph is defined between x equal to 0 and at x equal to this point. Okay, one more thing. Whenever we are looking for the domain, we always move horizontal. Why horizontal? Because x values lie always along the x-axis. So we move horizontally. So if we are looking at the domain, we will look for the x values horizontally. And whenever we have to find out the range, meaning the y, so as we know that y moves vertically, so for range we look at the vertical values, the values between which the graph is lying, that will give you the range. Horizontal, you can say boundaries are the domain, vertical boundaries are the range. Okay, so for domain, horizontally it is defined from x equal to 0 to this point. So this is 5, 6, 7 and 8. So domain is, and is it continuous or discrete? It looks like discrete because grid is given, but this is continuous because curve is continuous. So at x equal to 1.1 also you are getting the value, sorry, this is 0.1, right? At x equal to 0.999 also you are having some value, though we are not able to find out the exact value, but the function is defined. So it will be a continuous set, meaning domain will be given inside the square bracket or parenthesis, and function is defined at these endpoint also. So domain is that x belongs to square bracket from 0 to 8. Horizontally, the curve is lying between this, and range, you can write either y or just fx, belongs to, vertically it is lying between these points. So this is 0, -1, -2, and this is 2, and this is 3. So between -2 and 3, function is lying. So square bracket -2 and +3. Okay, fine. I think yes, couple of question of domain also. So as we have learned, this is type 2, sorry, in which square root something is written. So for a square root, x plus 2 must be greater than 0. So domain for this is that x belongs to, x is greater than equal to -2. So x belongs to -2 till infinity. Okay, and for this, x square minus x should not be equal to 0. This is of type 1, 1 upon a. A should not be equal to 0. Okay, so x minus 1 should not be equal to 0, meaning x should not be equal to 0 and x should not be equal to +1. If you put x equal to 1, this will be 1 minus 1, again 1 by 0, not allowed. And if you put x equal to 0, it will be 1 upon 0, so again not allowed. Rest all the values are allowed. So only for these two discrete values, domain, these two values should not be in the domain. Rest for all values, function is defined. So domain for this is that x belongs to all real numbers except these two values which are 0 and 1. This is the domain. Okay. So that's all for today. I think the lecture is very long, but since I told you that if we are going in details, duration of the lesson will be more. All right. So in the next topic, we will do transformation of functions. You keep on practicing the question of domain and range, and there are certain questions, means finding out the range is a bit interesting. I would say, I won't say difficult, but it is interesting because there are various ways. It is not that direct. How directly we have find out the domain, it is not that easy for the range. Okay. So if time permits, we will do some question of range also. Otherwise, we will move to the next topic, which is transformation of functions. All right. Thank you for your patience and take care. See you soon.